Hey guys, welcome back to another video, and in today's video we'll be looking into the various units of the fundamental quantities in the SI system. So in the previous video we did looked upon the time, and we looked into the history, like how the history what history tells us about the time and how people measured time in the very basic very original origin days, and how it got precise day by day. Looking forward, we will be looking into today the remaining units, that is for mass, current, temperature, luminous intensity, mole. So first of all we have got the mass, so let's get into it. Like, mass is measured in kilogram. So how we can say that we have got a particular amount of substance, we have got a particular mass, then that is 1 kg. How we can say that? Basically the history lies where that we have got a cylinder alloy. We have got a cylinder alloy that is kept at international bureau of various standards and various nations, France, Paris. So this is uh, uh, alloy. There is a basically cylinder alloy, cylinder shaped. This is a cylinder shaped alloy, and that is kept at international bureau of various nation, France, Paris. And what is the constitution of the alloy? It is like 90% platinum and 10% iridium, right? 90% platinum and 10% iridium, and we do consider that as 1 kg. Like, we have got the cylinder diameter kept is diameter is 3.9 centimeter, while we have also got the length, that is also 3.9 centimeter. Like, the length and diameter are both the same, and this particular amount of matter is termed as 1 meter, that is kept safe and secure in international barrier of units and France, Paris. And as we know that mass is neither destroyed, it is as it is kept in conditions and safe and secure. There's not any chance of losing the mass. And what happened was that uh, when we did prefer that this is 1 kg, we have got copies of it and were supplied throughout the world, and that is how we have got 1 kg blocks in our home. I do hope that you understand the mass. Moving forward, we have got current. So current is basically measured in 10 amperes. We have got 1 ampere, 2 ampere, 3 ampere current. So if that, we know that current formula is I is equal to Q upon T, right? I is equal to Q upon T. I for current, I if current is equal to Q, charge per T time. Current is equal to charge per unit time, flow of charge per unit time. So in the similar way, for the one we write current, we have written 1 ampere is equal to charge, that is 1 coulomb upon 1 second. Like, here 1 coulomb is equal to 6.25 to 10 to the power 10 to the power 18 electrons. And uh, this is you can make the definition like 1 ampere current is equal to the flow of 6.25 into 10 to the power 18 electrons in a second. So that is that amount of charge being carried in 1 second is termed as 1 ampere of current. We have got another way to determine this as well. Like, we have got two wires placed in a vacuum. This is a vacuum, and we have got two wires, this one and this one, and the current is flowing in the same direction among this, and we've got same direction current in both, like, and there is a force, repulsive force applying between them. Like, we have got, if there were opposite direction, so we have got repulsive force. They are having same direction, there is a attractive force, and the magnitude of the force is like this: 2.2 into 10 to the power minus 7 newton. And they have got a distance of 1 meter. So we have got a condition that when two parallel wires placed in a vacuum with a distance of 1 meter have got uh, attractive force of 2 into 10 to the power minus 7 newton, so the amount of current being flowed in these conditions is termed as 1 ampere, right? Moving forward, we have got temperature. So temperature is measured in Kelvin, and 1 Kelvin is equal to triple point of water. uh, Yes, triple point. You know what is triple point of water? The triple point of water is something where all the three states of water do exist, and we've also got temperatures for that. Like triple point of water is 273.16 Kelvin, or we can say 0.01 degree Celsius, and that is 1 degree Kelvin. We can say that one fraction, or we can say that 1 upon triple point of water, triple point of water, or we can say that 1 upon 273 is equal to 1 Kelvin, right? This is how volcano is layered. Now we have got next look into the next quantity, that is the luminous intensity. That is quite simple. Let's suppose, okay, luminous inten intensity, luminous intensity, and that is measured in candela. Candela got CD, and the luminous intensity, we can say that uh, one candela is equal to light which is being focused in one part of 6 into 10 to the power 5 square kilometers. 10 to the power 5 square meters. Okay, so like we have got a surface, and we've got this surface. We've got this surface, and this is 6 into 10 to the power 5 area square kilometer. Okay, we can say that this is like this. This is this is this is the area. We can say that this is the area of this, and what is happening is that we have got one fraction. We do this much parts of this area of this 6 into 10 to the power 5 square meter area. We have got light over light. We have got light over this part. So this one fraction is equal to 1 candela. This amount of current is equal to 1 candela, right? So what we have got next is the mole. Mole is the amount of substance. What mole, right? Mole is equal to amount of substance, right? Mole is basically amount of substance. We can say 1 mole is equal to atomic mass, moly mass expressed in grams, with relative mass of C12 atom, right? 1 mole of substance is equal to the atomic mass, like uh, we've got we've got here carbon, like we have got carbon. So 1 mole mole of carbon is equal to 12 gram, 12 gram. And in the same way, 1 mole of H2O, H2O. So we got take out the molecular mass, that is 16 plus 2, 18. 18 gram is equal to 1 mole of water. We take 18 gram water, so that would be equal to 1 mole of water. We have got relative. We have got relative the C12 atom, that is, you can see that 12 gram of carbon is equal to 1 mole of substance, and that can be 0.012 kg as well. And the simplest way is, we can say that 1 mole has 6.023 into 10 to the power 23 entities. 1 mole of substance is equal to 6.023 into 10 to the power 23 entities. Entities can be atoms, molecules, something like we have got atomic formula, molecular formula. So we can say that uh, 12 gram, that is 1 mole of carbon, would be having, okay, this number is also called Avogadro number, and that is Na. We determine by Na, right? This value is called Na, or we can say Avogadro number. So 1 mole of carbon is equal to 12 gram, and the number of atoms in it is Na. The number of atoms got is Na. In other words, 1 mole of H2O is equal to 18 gram, and 1 mole of H2O contains Na number of molecules. So I do hope that you got cleared it out. Meet you in the next video. Thank you for watching.